Hello viewers. So in this video, we'll be looking at trigonometry ratios for a right angle triangle. So as you can see here in figure 1, this is a right angle triangle. A right angle triangle is an angle where by one of the angle is a right angle. In other words, it's 90 degree. So as you can see here, we have a 90-degree angle here, and here you have our theta, right? So where you can see where the right angle is facing, the opposite of the right angle is what we call the hypotenuse, which we can denote by the letter R. And here you see the opposite of where the theta is facing is called your opposite. Let's call it Y. And the distance between the distance between the right angle and your acute angle, theta. An acute angle is an angle that is less than 90. It's your adjacent, which is called x. And one thing you can see by Pythagoras theorem, you can see that if you have r squared, it's going to be x squared plus what? Plus y squared. So it means r itself is the square root of x squared plus what? Plus y squared. And now if you come here, we can also use, you see sine theta. Sine theta is what? Is opposite over hypotenuse. So if this is theta, opposite is where? Is y. So this is y over hypotenuse, which is r. So it means here, what is cosec theta? Cosec theta is just the reverse, which will just be r over y. And then when you talk of cos theta is adjacent over hypotenuse. So what is the adjacent? As you can see, the adjacent is what? Is x, and hypotenuse is still r. Then the reciprocal of cosec theta is sec theta, which is nothing but r over what? Over x. Then we go to tan theta. Tan theta is opposite over adjacent, which is y over what? Over x. Y cotan theta is the reciprocal, which is adjacent over hypotenuse. And you can see adjacent is x, and adjacent over opposite, so which is just x over y. So one thing we can use to recall is we can use what we call the SOHCAHTOA. So what is SOHCAHTOA? SOHCAHTOA, the S in SOHCAHTOA stands for sine. The O stands for opposite. So the H stands for what? Hypotenuse. So what does that mean? It means that if you are looking for sine, it's just followed by what is opposite over the hypotenuse. So you take the ratio of the two sides. So C here is cosine, and you can see K here is A, which means stands for adjacent, and H again is hypotenuse. So it means that what? It means that if you are looking for what? For sine, we take opposite over hypotenuse. And if you are looking for cosine, it's going to be adjacent over hypotenuse. Then finally, if you're looking for tan is going to be opposite TOA. So it's TOA. This is going to be opposite over adjacent. All right. So let's look at this example 1. Example 1 here is that we want to find the 6 trigonometric ratios of theta in this diagram. So what we need to do is we need to identify where is our opposite, hypotenuse, and adjacent. Now, the place where the right angle is facing, the side that is opposite to the right angle is usually our hypotenuse. So this is our R. So it means R is equals to 3. Now, the place where it's opposite to our theta, the acute angle, is usually our opposite, which we normally use as what? As Y. So this is Y. And the distance between your right angle and your theta is x. So with this, we can start with sine theta, which we know is what? Is y over r. And this is just going to be 2 over 3. And immediately from here, we can get cosec theta, which is just going to be the reciprocal, which is 3/2. Then for cosine theta is adjacent, so this is x over r as well. Adjacent over what? Hypotenuse, which is x over r. This is going to be √5 over what? Over 3. And this also means that sec theta is going to be 3 over √5, which we can rationalize if you want. You can leave it like that, or you can rationalize to be 3√5 over 5, right? Then for tan theta is just what? Y over what? Over x. And what is y? You can see y is 2 over √5. And that means that cotan theta is just going to be √5 over what? Over 2. Okay, so these are the 6 trigonometry ratios from this diagram. All right, example number 2. It says that if cosine alpha is 3 over 4, where alpha is an acute angle, we want to find the other trigonometry ratios. So here in this type of question, what you do, just draw your right angle triangle somewhere. And you can call here to be your right angle. If you like, you can call here to be alpha. It's fine. So since this is cosine, cosine is what? Cosine is, remember, is adjacent over hypotenuse, right? And remember, what is adjacent? Adjacent is usually the x, and hypotenuse is the r. So here we can see that what this is going to be, this is the right angle where you put the right angle. So this is going to be our y, right? And where the alpha is facing is usually our opposites. Yes. So now our opposite, which is the y, right? And then we can easily find what is the radius, not the radius, but we can find it. All right. So here is our y, and this is going to be our adjacent, and this is going to be our hypotenuse. So it means that cosine alpha is going to be x. So it means this is 3 and hypotenuse. So it means this is going to be 4. Yes. So it means x is 3. So now you can see we can use Pythagoras theorem to get the other side. Because from Pythagoras theorem, remember, we will have r squared is equals to x squared plus y squared. So now what is r squared? This is going to be 4 squared is equals to 3 squared, then plus what? Y squared. So we'll have y squared, 4 squared minus 3 squared is going to be y squared. And this is nothing but what? 16 minus 9. And this is y squared. So this is 7 is equals to y squared. So y is root of what? Root of 7. See, so it means this is equals to root of 7. So now we can find everything. Remember, we are looking for the 5 other trigonometry ratios. We already have cosine. So let's go for sine alpha. Sine alpha is what? Is y over r. And now which is going to be √7 over what? Over 4. Clearly from here, we can get cosec of alpha, which is just going to be 4 over √7. Then we go for what? Here we already have cosine. Since we already have cosine alpha to be 3 over 4, then we can just get what? We can get sec alpha, which is going to be what? 4 over what? 4 over 3. For tan alpha, what is tan? Tan is y over what? X, which is opposite over adjacent. And now this is what? What is y? is root 7 over x, which is 3, right? Yes. And now from here, we can get what is cotan alpha, which is going to be 3 over root of what? Root of 7. And we are done. Okay. So this is, now let's look at special triangles. And here we will just, we'll just get some special triangles out here. So what are these special triangles here? If you look here, we just want to get the trigonometric ratios for 30, 60, and 45, which we will look at. So I think we can have that in another short video.